Hey guys, welcome back to my channel. In this video, I will be documenting my journey through Splunk. Join me on my journey. Let's learn Splunk together. We'll start with a basic search of Splunk on Google. All these courses are $0. There we go. All right, now that we are all signed in,
Hello, welcome to Introduction to Splunk. I'm Alex with Splunk Education. We're so glad you're here with us, beginning your journey of learning about Splunk. Whether your goal is to become a Splunk Enterprise admin, run searches and build dashboards in a Splunk cloud environment, or dive deeper into your data using one of our premium solutions like Enterprise Security or Splunk SOAR. In this course, we'll cover what Splunk is and get hands-on with the interface, running searches, and using commands to create reports and dashboards. We'll learn about how knowledge objects can help enrich your data and how to integrate them into your overall workflow. The scenarios in this course will focus on data ingested by Buttercup Games, a fictional gaming company with offices in San Francisco, Boston, and London. Their games are sold by vendors across the globe, as well as in their online store. They ingest data from their online and retail sales, as well as game logs, firewall and web security appliance data, and internal security data related to badge reader access and Active Directory credentials. In the past, when a customer would contact support with an issue, the problem would be handed from one team member to another, forcing everyone to drop what they're doing and manually diagnose the problem, costing time and resources, and frustrating everyone in the process, including the customer. But with Splunk's suite of products, they can use all the data in their environment to solve the issue in less time. When the support request comes in, it's automatically routed to application support, where Caesar searches the data for events where purchase attempts ended in an error. He can then pinpoint the event that matches the user's experience. That event is tied to a database query, which can be correlated to an entry in the slow query log, allowing Caesar to escalate the issue to his admin in a matter of minutes without having to get the whole team involved. But better yet, what if we could alert when transactions fail, even before the customer calls tech support, enabling Caesar to triage the problem before it leads to bigger issues down the line? Splunk is a unified data platform that allows teams to work together or individually to ensure mission-critical digital systems stay secure and reliable. Whether you are on an IT ops, DevOps, or SecOps team, Splunk can provide the key to enterprise resilience and help build a safer digital world. Splunk's primary features make your machine data available, accessible, and usable to everyone in your organization. At the heart of Splunk is the index, which contains your machine data from sources such as servers, network devices, and web applications. Think of your indexer as a factory and your data as raw materials. As data enters, inspectors go to work. They look at the data to decide how to process it. When they find a match, they label the data with a source type. That source type is then used to break the data into single events. The timestamps are identified and normalized to a consistent format. Once data is ingested into the index, it is available for searching and analyzing. By entering a query into the Splunk search bar, you can find events that contain values across multiple data sources, allowing you to analyze and run statistics on the events using the Splunk search language. Search results can be saved to reports, which can provide continued insights into your data and can be used to power dashboard panels. Knowledge can be organized into structured datasets called data models to allow users to quickly visualize data in Pivot without having to write custom searches. To stay on top of your environment, alerts allow you to set custom triggers, so you're notified and can respond to incidents as soon as they occur. Can be saved to reports, which can Let's take a look at the Splunk web interface. After logging into Splunk Enterprise, you'll be redirected to the Splunk Home app. Apps are pre-configured environments that sit on top of your Splunk instance, extending its pre-built knowledge and capabilities. You can think of them as workspaces, built to solve a specific use case. The apps you see are defined by a user with an administrator role. Roles determine what a user is able to see, do, and interact with. There are 3 predefined default roles in Splunk Enterprise: the administrator role, the power role, and the user role. The administrator role is the most powerful, can install apps, ingest data, and create knowledge objects for all users. The power role can create and share knowledge objects with all users of an app, and perform real-time searches. The user role will only see their own knowledge objects, and those that have been shared with them. Our role can create and share knowledge objects with all users of an app, and perform Our role can create and share knowledge objects with all users of an app, and perform real-time searches. The user role will only see their own knowledge objects, and those that have been shared with them. Similarly, Splunk Cloud ships with the roles of SC Admin, Power, and User, as well as additional cloud-specific roles. The Home app gives you a quick place to explore Splunk Enterprise. It allows you to launch and manage other Splunk apps, find documentation, and set a custom dashboard as your default dashboard. Admins or users with the appropriate capabilities can also add apps and data from here. Hundreds of apps are available on Splunkbase, or you can build your own. I have added a link to Splunkbase to your notes. The Search and Reporting app provides a default interface for searching and analyzing data. There are 8 main components of the Search and Reporting app's interface. The Splunk bar appears on every page in Splunk. You can use it to switch between apps, edit your account, view system-level messages, manage and edit your Splunk configuration, monitor the progress of search jobs, and find help. The app bar allows you to navigate the application. The search bar is used to run searches. You type in your search string and hit enter, or click the search icon to start a search. The time range picker is used to retrieve events over a specific time period. There is a How to Search panel with links to documentation and a search tutorial. By selecting the Data Summary button, you get a breakdown of the data indexed by host, source, and source types. There is a How to Search panel with links to documentation and a search tutorial. By selecting the Data Summary button, you get a breakdown of the data indexed by host, source, and source types. We talked earlier about source types being a classification of your data. The source is the file or directory path, network port, or script from which the event originated. And the host is the host name, IP address, or fully qualified domain name of the machine from which the event originated. Table Views provides a UI-driven way to explore and prepare your data without using Splunk's search processing language. The Search History menu allows you to view and rerun past searches. We can narrow our search history by entering search terms into the filter window, and filter to show searches executed today, over the last 7 days, or over the last 30 days.
This is a nice representation to show you how much percentage have you completed the course. Once you start a course or you play the part of that course, it already completes to half, 50% completed. And you actually have to click on continue to make it fully 100% complete after you watch the video.
Now that we're familiar with Splunk's Search and Reporting app interface, let's take a look at how we can search our data to investigate a potential security issue. Let's check in with our colleague Caesar. This morning, Caesar was killing time on his favorite social network when he got a message that there was some suspicious-looking activity on one of the Buttercup Games servers. We'll use the Search and Reporting app to help Caesar see what is happening on the server. The search bar works as you would expect it to. We just enter the information we want to search for. To see if someone is trying to log into our server using bad credentials and failing, we type failed into the search bar. As we type, the Splunk Search Assistant will display matching terms, contextual matches, and syntax documentation for the search. As we type, the Splunk Search Assistant will display matching terms, contextual matches, and syntax documentation for the search. We only want to see when failures have happened over the last week, so we select last 7 days in the time range picker. Limiting a search by time is key to getting results faster and is a best practice to use for every search. Once the time range is selected, the search is sent to Splunk, where it becomes a search job. The new search page opens. A search by time is key to getting results faster and is a best practice to use for every search. Once the time range is selected, the search is sent to Splunk, where it becomes a search job. The new search page opens. The interface now contains a Save As menu, search result tabs, search action buttons, a search mode selector, and a timeline. The events containing the text we searched search action buttons is a best practice to use for every search. Once the time range is selected, the search is sent to Splunk, where it becomes a search job. The new search page opens. The interface now contains a Save As menu, search result tabs, search action buttons, a search mode selector, and a timeline. The events containing the text we searched for show in the event list, and the fields that were extracted show up in the fields sidebar. The Save As menu allows us to save our search as a knowledge object. The results populate into the search result tabs depending on the type of search commands used in the search. The Events tab will display the events returned for your search, and the fields that were extracted from the events. For a simple search like this, you will usually be presented with this tab by default. The Patterns tab allows you to see patterns in your data, allowing you to get a better understanding of what is happening in your data. If your search is generating statistics or visuals, they will be displayed in the Statistics or Visualization tabs. If not, links for Instant Pivot, Quick Reports, and search command documentation will be displayed. Where it becomes a search job. One quick note: commands that create statistics and visualizations are called transforming commands. These are commands that transform event data into data tables. We will learn more about transforming commands in a future video. Right above the search result tabs, we see the total events returned, and an option to return a random sample of these events. The search action buttons allow us to edit, send to background, inspect, and delete search jobs. There are icons to pause, stop, share, print, or export a search job. Selecting the share icon, we get a link that we can share with others or bookmark for our own use. By default, a search job will remain active for 10 minutes after it is run. After 10 minutes, Splunk will need to run the job again to return the results. A shared search job, on the other hand, will remain active for 7 days and will be readable by everyone, meaning that anyone you share this job with will see the same exact results you did when you first ran it. The export icon will allow you to export events returned from the job in RAW, CSV, XML, or JSON formats. There are 3 search modes you can choose from the search mode selector: Fast, Smart, and Verbose. With Fast cutting down on the field information that is returned, field discovery is disabled for this mode, only returning information on default fields and fields required to fulfill your search. Verbose mode returns as much field and event data as possible, discovering all the fields it can. The default Smart mode will toggle behavior based on the type of search you are running. The timeline is a visual representation of events segmented over time. The segments are dynamically decided by the time you choose in the time range picker. In this case, we see a segment for each hour over the last 7 days. We can select a specific time range in the timeline to investigate. Doing so, our event list updates to show just the events selected. We can also use the zoom links to zoom in and out of a selection. Now that we can see the events that failed, let's look at how we can start using the events and fields to dig a little deeper. Let's take a closer look at how to use events returned by a search. When a search is run, it will return a list of events. We can use returned events to expand our searches and interact with our data. In the events list, the text we searched for is highlighted, and events are returned in reverse chronological order, showing the newest events first. While time is normalized in your index to a consistent format, the timestamp you see in the events is based off the time zone set in your user account. In this example, we see a 3-hour difference displayed for an event with a user setting of Pacific time compared to a user with a setting of Eastern time. Across the bottom of each event, we see selected fields. Currently, we have the default selected fields of host, the hour difference displayed. The timestamp you see in the events is based off the time zone set in your user search for is highlighted, and events are returned in reverse chronological order, showing the newest events first. While time is normalized in your index to a consistent format, the timestamp you see in the events is based off the time zone set in your user account. In this example, we see a 3-hour difference displayed for an event with a user setting of Pacific time compared to a user with a setting of Eastern time. Across the bottom of each event, we see selected fields. Currently, we have the default selected fields of host, source, and source type. Rolling over text in an event will highlight it. Clicking on the highlighted text allows you to add that text to the search, exclude events that contain that text, or launch a new search using the text. Each option has an icon that will open the redefined search into a new browser window. We add password to the search updates in the search bar, and highlighted text allows you to add that text to the search, exclude events that contain that text, or launch a new search using the text. Each option has an icon that will open the redefined search into a new browser window. We add password to the search updates in the search bar, and the new events are returned. Clicking on the highlighted text again will allow you to remove it from the search. Selecting the info button next to an event, we see all the extracted fields for the event, with check marks next to the selected fields. There is a dropdown for event actions and a link for field actions. There are many options when searching terms in Splunk. If we want to cast a wider net for any text that might indicate a failure, we can use a wildcard. Adding an asterisk to the end of the text fail will return any event that starts with the word fail, including fail, failure, and failed. Search terms are not case sensitive, so no matter how we capitalize a value, all results matching the term will be returned. Uppercase booleans of and, or, and not can be used with multiple terms. So if we want to see events with the text failed, but not password, we add a boolean of not. Or all events containing the text failed or password, we use an or boolean. If no boolean is used, and is implied. Boolean operations have an order of evaluation. Using not, but not password, we add a boolean of not. Or all events containing the text failed or password, we use an or boolean. If no boolean is used, and is implied. Boolean operations have an order of evaluation. Text failed or password, we use an or boolean. If no boolean is used, and is implied. Boolean operations have an order of evaluation, using not clauses first, then or, and finally and. Parentheses can be used to control the order of evaluation. As an example, by adding parentheses around the or statement in these search terms, Splunk will first evaluate the terms in the parentheses. Exact phrases can be searched by placing the terms in quotes. There might be times when you are looking for results that contain quotes. You can use a backslash character to escape quotes. Let's look at how to use commands to do more with our search results. Splunk's search language is built from 5 components. Search terms are the foundation of search queries. Commands tell Splunk what we want to do with the search results. This includes creating charts, computing statistics, and formatting. Functions explain how we want to chart, compute, and evaluate the results. Arguments are the variables that we want to apply to the function. And clauses explain how we want results grouped or defined. Let's look at how these are put together into a search. We will talk about the specific components in a little bit, so don't worry if you don't understand what they are doing quite yet. First, we have the search terms, then the first search component. You can see that inside this stats command, there is a function of count, with an argument of usage. The as is the clause. These two search components are separated by a pipe. We use a pipe to tell Splunk to pass the current results on to the next component. Our existing query searches our web security appliance data in the network index to count the number of visits there have been to prohibited sites from our environment over the last 30 days, then stores that count in a field called visits. By appending a by clause with the CS username field, we can further split the count of these events by individual employees. The search command can be used to filter results at any time in the search pipeline. The command behaves exactly like the search terms before your first pipe, but allows you to filter your results further down the search pipeline. We can use this command with the visits field we created in the stats command to find employees that have violated our web policy more than once this month. While being able to search inside your pipeline is very powerful, remember that if you can filter the items before your first pipe, do it there for better searches. We previously discussed case sensitivity for search terms. Command names, clauses, and functions are also not case sensitive. If a command references a specific value, that value will be case sensitive. As an example, if we want to replace one of our host values using the replace command, it's required that the host value be an exact match, including case. Using time to limit the events returned is the most efficient way to filter events. The less data you have to search, the faster Splunk will be. After time, the default fields of index, source, host, and source type are the most powerful. These fields are extracted at index time, so they will not need to be extracted for each search. The more you tell the search engine, the more likely it is that you will get good results. It's better to search for failed password instead of just password. Inclusion is generally better than exclusion. Searching for is that you will get good results. It's better to search for failed password instead of just password. Inclusion is generally better than exclusion. Searching for access denied is better than searching for not access granted. When possible, use the or or in operators instead of wildcards. Apply filtering commands as early as possible in your search. Filtering early limits the number of events, making future manipulations of the data faster. Knowledge objects are tools that help you and your users discover and analyze your data. Knowledge objects are grouped into 5 categories: data interpretation, classification, enrichment, normalization, and search time mapping of knowledge called data models. Knowledge objects are useful in Splunk for several reasons. They can be created by one user and shared with other users based on permission settings. They can be saved and reused by multiple people or in multiple apps. And they can be used in a search. These make knowledge objects powerful tools for your Splunk deployment. Knowledge managers are responsible for overseeing knowledge object creation and usage for a Splunk deployment, implementing best practices for naming conventions, normalizing event data, and creating data models for pivot users, keeping the toolbox clean and efficient. Whether or not you're a knowledge manager in your environment, it's important for all Splunk users to know a little about the types of knowledge objects that exist. Let's take a quick look. Some fields are it's important. Whether or not you're a knowledge manager in your environment, it's important for all Splunk users to know a little about the types of knowledge objects that exist. Let's take a quick look. Some fields are automatically extracted from data based on the selected source type, but additional fields can be manually extracted to add additional insight to your data. Calculated fields are added to events at search time and perform calculations based on the values of existing fields. Event types allow you to categorize events based on search terms. Transactions are groups of conceptually related events that span time. Lookups allow you to add other fields and values to your events, not included in the indexed data. Workflow actions let us create links within events that interact with external resources or narrow our search. Tags allow you to designate descriptive names for key value pairs. They enable you to search for events that contain particular field values. You can think of them as labels for your data. Field aliases give you a way to normalize data over multiple sources. You can assign one or more aliases to any extracted field and apply to fields from a lookup table. And finally, data models are hierarchically structured datasets, which may consist of events, searches, and/or transactions. So far, we've learned how to successfully craft searches that return the events we want. But what if we need to run the search in the future, or we want to share that search with other users? We can make a note of our searches or email them, but that could get messy and annoying. Splunk makes saving and sharing searches simple with reports. Here, we have a search that returns events containing failed login attempts. 1 or 2 failed logins may just be due to user error, but multiple failed logins may be indicative of a security incident. Our team is particularly interested in seeing where these attempts happened. But when we look at the field sidebar, we don't see anything related to geographic information. We'll append the IP location command with the source IP field to add geographic context to the returned events. Now, in the field sidebar, we see that additional fields have been added to our results. Expanding the country field, we see the top 10 values for the field, along with a count of events that contained the value and the percentage of total events in this time period where the value occurred. At the top of this window, we see 4 links for quick reports: top values by time, rare values, or events with this field. Selecting top values appends the top command to our search and allows us to visualize this data in a bar or column chart. This is helpful, but in order to really understand where these attacks are coming from and see if there might be any trends in related areas, we'd like to visualize our results on a map. We'll replace our top command with a geostats command, which allows us to use the context provided by the IP location command to plot our data on a cluster or choropleth map. Hey Caesar, should web administrators be logging in from these locations? In order to easily share access to this data with our colleagues, we'll save it as a report by opening the Save As menu and selecting report. In the Save as Report dialog, we enter a name or choropleth map. Hey Caesar, should web administrators be logging in from these locations? In order to easily share access to this data with our colleagues, we'll save it as a report by opening the Save As menu and selecting Report. In the Save As Report dialog, we enter a name, optional description, confirm that we want to display this data in a visualization, and select whether to display the time range picker or not. Before saving reports, it's best for your organization to define a naming convention. This will help keep your reports organized and easy to find. We use a naming convention of the group the report is for, the type of object it is, and a simple description of what the report contains. After saving, we are given a list of additional settings, but let's with our colleagues, we'll save it as a report by opening the Save As menu and selecting Report. In the Save As Report dialog, we enter a name, optional description, confirm that in order to easily share access to this data with our colleagues, we'll save it as a report by opening the Save As menu and selecting Report. In the Save As Report dialog, we enter a name, optional description, confirm that we want to display this data in a visualization, and select whether to display the time range picker or not. Before saving reports, it's best for your organization to define a naming convention. This will help keep your reports organized and easy to find. We use a naming convention of the group the report is for, the type of object it is, and a simple description of what the report contains. After saving, we are given a list of additional settings, but let's just view it for now. When a report is run, a fresh set of results is returned. Since we chose to show a time range picker, we can change the time range of the events shown. You can access all your reports from the Reports tab in the Application menu. You can run the report by selecting its title, or open it in Search. Selecting the arrow next to the name of the report expands to show details such as who created it and the app it was created in, as well as additional settings for scheduling or accelerating the report, and who has permission to view it. Edit links for these settings are available next to each setting, and can also be found by expanding the Edit menu. Here, you have options to edit description, permissions, schedule and acceleration, along with links to clone, embed, or delete the report if we have the proper permissions. When a report is created, it is set to display only for the owner who created it. By changing this display setting to App, we can share this report with all other users of the app in which it was created. In this case, Search and Reporting. By default, the option to display a report in all apps is only available to users with an admin role. Power users are granted read and write permissions on the report. Notice the Run As dialog. This allows the report to either be run as the owner of the report or as the user that is running the report. So if you have sensitive materials that not all users of your organization should see in the report, and the report is run as owner, the data could be returned to the user. If the report was run as user, only the data they have access to would be shown. We can schedule the report to run at timed intervals using the Edit Schedule link. There are multiple benefits to scheduling a report. It can reduce strain on your environment caused by repeatedly running new ad hoc searches. This is particularly beneficial when a report is shared with a number of users or embedded in a dashboard. Reports can be configured to run every hour, day, month, or week, or you can tune them even more by defining a cron schedule. We see a warning at the top of the schedule window for this report, letting us know that scheduling a report will override our Run As settings, and will remove the time range picker from the report, since the intention is to restrict how often the report will run and what data it will access. We can specify a time range and give it a schedule window in case there are multiple concurrent searches, and specify a time range and give it a schedule window in case there are multiple concurrent searches scheduled to run at the same time. Trigger actions can further enhance your report's functionality, delivering scheduled search results via email, using a webhook to post results to an external URL, or custom scripts defined by your organization. Sometimes a visualization will help you use your data to tell a better story. Splunk allows you to visualize your data in many ways. Any search that returns statistical values can be viewed as a chart. Now that we know where our failed logins are coming from, let's investigate further and figure out what accounts are associated with those events. We'll start with the same search terms we previously used to create a report. Expanding the user field in the field sidebar, we'll again use the Quick Reports option to find the accounts most commonly experiencing login failures. This appends the top command to our search, allowing us to visualize the results. Hovering over a segment of where our failed logins are coming from, let's investigate further and figure out what accounts are associated with those events. We'll start with the same search terms we previously used to create a report. Expanding the user field in the field sidebar, we'll again use the Quick Reports option to find the accounts most commonly experiencing login failures. This appends the top command to our search, allowing us to visualize the results. Hovering over a segment of a chart will display statistics for the segment. There are many types of visualizations in Splunk Enterprise, so you can find the right chart for your data and format it to best tell your story. The Visualizations tab contains options to select a visualization that best fits our data or customize it using the Format menu. We'll display these results in a pie chart. The top command defaults to display the 20 most common values for a supplied field. 20 looks a little crowded in this visualization, and we want to make sure we're focusing on our most common offenders. So we'll change the number of results returned to 10. There we go, much easier to read. We'll share these results with our colleagues by saving it directly to a dashboard. Expanding the Save As menu, we have the option to save this visualization to a new or existing dashboard. We'll select New Dashboard, then give it a name. We have the option to add a description and can set permissions to allow others to view our dashboard. We'll leave this as private for now while we're still developing it. Splunk offers two different frameworks for building dashboards: Classic Dashboards or Dashboard Studio. We'll touch on the differences a little later, but for now, let's select Classic Dashboards. We give the panel a title and confirm that we want to display our results as a visualization and not a statistics chart. Under Advanced Panel Settings, we see that this panel is powered by the inline search we just ran, and that drill down is not enabled for this dashboard panel. Drill down behavior can be configured to make your dashboards interactive, allowing users to explore data beyond just what they see in the default dashboard view. This setting can be modified in the dashboard editor once the dashboard has been created. Our settings look good, so we save and view the dashboard. Let's add some more panels to our dashboard to tell a more comprehensive story. Returning to the new search page, we'll again search for the terms we used to visualize our most common users experiencing login failures. Let's look at events by time, so that we can see if there are any concerning spikes in login attempts. While failures are our primary concern, a spike in accepted login attempts can also hint at a potential security incident. So we'll delete the failed password requirement to return all events related to login activity. In the field sidebar, we expand the Action field, where we can confirm we're now seeing results from both failures and successes. Selecting the Top Values by Time Quick Report appends the time chart command to our search, so we can visualize our data as a line chart, allowing us to quickly see login trends over time. This looks good, but before we save it to our dashboard, we'll make a couple of visual modifications. Options in the Format menu will differ based on the visualization type. For example, if we change this visualization to a column chart, in the General tab, we see that we have options to change stack mode, offering different ways of thinking about how our failed and successful logins compare to one another. For our line chart visualization, we have some general settings, format options for the X and Y axis, a chart overlay option if we want to compare values from a different field, and options for our legend. We'll change the legend's position to move it to the left side of the visualization. We'll also choose to display values for our minimum and maximum data points. Now we'll save this panel to our existing dashboard and view our progress. Looking good. Additional panels can be added to our dashboard by selecting Edit, then Add Panel. In the Add Panel window, we have options to create a new visualization from scratch without returning to the search window. Add a panel from a report, clone a panel from another dashboard, or add a pre-built panel. Let's add a panel containing our cluster map visualization inside the report we previously created. We'll select New from Report, then select the report's title. A preview of the visualization is displayed, along with the details of the report and the underlying search that powers it. When we select Add to Dashboard, the panel is added to the bottom of the dashboard. Our dashboard is starting to tell a story, but could use some visual optimization. We'll move our cluster map displaying failed login attempts next to the pie chart displaying attempts by user, and change its name to be a little more human readable. While in edit mode, we also have options to see and edit the XML source for our dashboard, add inputs, and select a dark theme for our dashboard. We also have tools on each panel allowing us to edit searches, change visualizations, and modify visualization formats, along with other actions. In the drill down editor, we can configure behavior when users interact with a visualization, linking to search, another dashboard, a report, custom URL, or manage tokens for more advanced drill down capability. Let's link this visualization back to its search, save the dashboard, and refresh the dashboard to ensure that the changes have been applied. Now when we select a slice of our pie chart, a search window opens that contains the events related to that user, with the selected user already populated in the search. And, of course, our map displaying failed login. While in edit mode, we also have options to see and edit searches, change visualizations, and modify visualization formats, along with other actions. In the drill down editor, we can configure behavior when users interact with a visualization, linking to search, another dashboard, a report, custom URL, or manage tokens for more advanced drill down capability. Let's link this visualization back to its search, save the dashboard, and refresh the dashboard to ensure that the changes have been applied. Now when we select a slice of our pie chart, a search window opens that contains the events related to that user, with the selected user already populated in the search. And, of course, we can access all of our dashboards by selecting the Dashboards tab. When we created our dashboard, we had the choice of one of two frameworks: Classic Dashboards and Dashboard Studio. Using our existing dashboard, let's take a quick look at the features of Dashboard Studio. Navigating to the Dashboards tab, we open our existing dashboard. Expanding the menu at the top right corner of the interface, we select Clone in Dashboard Studio. We see the same options we had when creating a classic dashboard, to change the name and optional description of the dashboard, as well as define its permissions. Now we need to decide whether we want our dashboard to be in absolute or grid mode. Absolute layout offers pixel-perfect, fully customizable placement, while the grid layout offers automatic snap-to alignment to quickly organize your panels into rows. We'll select grid layout, then convert and save. The dashboard opens in edit mode. Icons at the top contain controls to add a new visualization, add inputs, add markdown text, show or hide the configuration panel, configure data sources, or edit the dashboard's JSON definition. The options available in the configuration panel will vary depending on the selected visualization. While the width and height of panels can be defined in classic dashboards by editing the XML source, Dashboard Studio makes it easy to customize your dashboard layout by selecting and dragging the boundaries.
We just completed our course for Splunk. Now time to test. How much information have we retained? I'll complete this quiz and good luck to me. So I passed the quiz. Let's see, what do we have here? Thank you for joining me, and join me on my journey on mastering Splunk. Comment, like, subscribe to the channel. See you next time.